Good evening.
Evening.
Good evening.
Rajay, mute your mic, please.
Good night, everyone.
Next, sir.
Oh, no, do.
Night, sir.
No, man. All right. So, all right. Trust that you had a good day today. Trust that no one is in commute and that you can give me your undivided. Um,
Excuse me, sir. I am in
yes.
commute because my car broke down on me today. So I have to take it to the garage
Oh no.
when
Osh.
I leave in work.
Osh. 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 Osh.
So
Osh. Osh.
on the way to about the next 5 minutes or so. I think I'll get
Oh.
it.
Oh no. All right. Just be safe, please. I hope you're using a hands-free device because them popo you know want enough money.
Too bad for them.
Yeah, trust me. Make sure you use a hands-free device here. All right.
Yes, sir.
So, all right. So we on yesterday, geez, I forget that is not Tuesday, Thursday. So yesterday we had an interesting session where we took almost, not almost, we took it 2 hours to 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 complete the a question that I gave, and I'm a little concerned that we may not be um so au fait with what is happening. So I'm just coming from a class, and while they were doing work for me in that class, I was just double checking to make sure that things are hunky dory. Oh, I'm sorry. I'm sorry. I need to. I'm trying to share my document and forget how to share from this device, but now I remember. And again, I forget that when I share the document, I need to unmute. All right. So I was saying that I'm a little concerned that you're not so au fait with what is happening, and I need to get you guys to that stage where you become not just proficient, but become a little bit more confident in what is happening. So here goes. So the question asked us to, it gave us a function, f of x is equals to x squared over x plus 1. Not a handsome looking function. The function is really not handsome or pretty, but it's a function. I don't know what function they will give you. They may give you the same right up, but a different function. To find the horizontal asymptote or the vertical asymptote, they may ask you to find the critical points, the relative maximum or minimum point of inflection, or to sketch a graph. The function may be a function that is not a pleasant one to look at, but nonetheless, we still have to work with it. That's just how it goes. You know the steps, work with the steps. So it says to find a horizontal asymptote. So the horizontal asymptote, you're going to allow the numerator to be equal to 0. The horizontal is going to be the numerator. So whatever the numerator is, I'm going to set it equals to 0. See it right here, so? I'm putting x squared is equal to 0. X squared is equal to 0. See it again? X squared is equal to 0. X squared is my numerator, and I'm setting it equal to 0. So the whole function equation now becomes x squared equals 0. When x squared is equal to 0, somebody was saying, sir, you're finding the square root of x, you're finding the square root of x squared, and you're finding the square root of 0. Yes. So the square root of x squared is equal to x, and the square root of 0 is equal to 0. So x is going to be equal to 0, whichever way you take it. So you know the horizontal asymptote. You know the horizontal asymptote is going to be when x is equal to 0. We now need to look at the vertical asymptote. The vertical asymptote is in the denominator. This x plus 1 is equal to 0. The vertical asymptote is going to be found when the denominator is equal to 0. I'm putting the denominator to be equal to 0. So I'm going to let x plus 1 to be equal to 0. See it right here, sir? I'm letting x plus 1 equal to 0. Why, sir? Because I'm trying to evaluate the vertical asymptote. I'm trying to evaluate the vertical asymptote. The asymptote is really a boundary that the graph can't cross. So we need to look at those. So we need to put the vertical and horizontal asymptote in first before we start sketching the graph, because it cannot exist in some areas. Why it cannot exist in some areas? Because the function becomes undefined. Oh, that means, sir, when x is equal to -1, this -1 here, and you substitute it into this function, -1 plus 1 is equal to 0. And you can't have a 0 in the denominator, R2. So because you can't have a 0 in the denominator, it makes a function now becomes undefined. It means that the graph is not defined in that particular area. There is no definition for the graph there because it's undefined. The graph does not exist at that point when x is equal to -1. So it exists -2? Yes, because we've got only one vertical asymptote. This is the only place on the graph that the graph is not defined by. That's the only place on the graph that the graph is not defined by. Then so now defined by this x equals 0. Let us check. 0 plus 1 is 1. And 1 can exist in the denominator. So it is defined by x equals 1. X equals 0. But it is not defined by x equal -1. The graph does not exist. The graph becomes undefined. Remember, you cannot have a 0 existing in the denominator. You cannot have a 0 existing in the denominator. So the graph is undefined. So there are some boundaries for that graph. It can't cross it. It gets very close to it, but it can't cross it. Extremely close to it, it will never cross it. It will appear that it's kissing, but it never kisses. All right? So that's very important for you to remember. It does not happen. It will never happen. So that's what the vertical asymptote is. That's what the horizontal asymptote is. It tells you the boundaries of the graph, where the graph cannot go across, where the graph is bounded by. All right? So are there any questions with the vertical and the horizontal asymptotes?
No, sir.
Is
Before you
Dijon here?
continue.
Go ahead, Carson.
All right, so from what I'm understanding, based on the you said that to find the horizontal and vertical asymptotes, right? You say that we must always define the what's the term now? Expression by as equal to 0. So when we get like say certain expressions, how should it's gonna sound weird when I say this, but say we had a graph and we could plot each expression. How would you it's kind of weird when I'm saying it. In cases where you'd have like two different values, how would you define those?
Sorry, you lost me. Two different values where?
No, I'm just trying to piece it together from your explanation.
So the graph will be defined everywhere else away from x equals -1. So anywhere, any other points you get, the graph will be defined there. You can plot the graph anywhere else. It's just like in Bible days. Father God said you can eat anything away from this one thing. Anything away from this one thing. Is what I'm saying?
Yeah. So if the horizontal asymptote had a value like say -2, we would plot the graph away from that value as well.
Absolutely. Absolutely.
Okay. That's what
So
that's what I
so
wanted to.
the asymptotes will tell you the boundaries.
Mm.
It's just like you buy a plot of land. The markers will tell you where to build your house. You know, funny story. I remember going into a particular community, um, somewhere close by our school, not walking distance, but you know, close by driving. And and I was looking for someone, um, and I saw something very strange. The house is built, but there is no base. So the window is there, but the base of the property is knocked out. And while I was walking, I looked at it and I was like, what on earth happened right here? Something don't make any sense. And when I got to my destination, I said to the person that I visited, I said, yo, what going right here, so? And they said, oh, the person got a loan from the bank. But you know, some people are very dishonest.
And
So
they couldn't pay it off.
no, they're not paying it off. What they do is they know where the boundary is, but they want a little bit more space than everybody else. So them go over their boundary. And what they call it is the buttons. And they went over it. So what the bank does is to if you're getting a loan for home repairs for $2 million, the bank is going to release $1 million to you, and then they will come and do their inspection before they release the other $1 million to you. It was when the bank went to look at the inspection, they recognized, but hold on, the buttons are not correct, and they had to lick it down at their expense. They never get approval of the other $1 million for argument's sake, and they had to knock it down because it don't make sense. So the point I'm making is, if you are building a house and you confine to the buttons of the property. I mean, the dimensions are fine. The quantity surveyor came and said, yeah, man, everything is fine, Uncle Dory. And then you decide now, say, boy, you want a little bit more space. So you go extend the back of your house and connect it to your wall, or just leave a little bit of walking space between the house and the wall because they want to put on another room. Chances are, when you're ready to sell that house can't sell if I go lick down the place. Not chances are, you will not be able because you have encroached on the plot of land. So you'll not be able to sell the house unless you're going to sell the house cash. But if it is that the person who is acquiring the house is getting a loan to acquire the house, when the quantity surveyors come to do the estimation, you see, you're recognizing calculus when we talk about the whole building again with calculus one, it comes back for calculus two. I mean, those architects and those engineers will have to have a good ground on calculus. So if you encroach, you cannot sell. You know, I know somebody personally who was living in a particular area near where Lotto lives and wanted to sell the property. And the truth of the matter is, when they came, they said, "No, man, this fence is not correct." Them say, from what it is that we have at the lands office, this is not correct. No, the lady wanted to sell the sales agreement almost come through, you know. The lady wanted to sell the property and move from there. So, and had to lick it down, had to spend money, lick it down, and carry it in a little bit more before they can do the stuff. So this is exactly what it is. There are boundaries that you cannot cross over. If you cross over, it becomes null and void. So this graph, f of x equals to x squared over x plus 1, is one of those things. You can build inside of this property. You cannot build anything past this line. This line is a line that says you cannot pass it. You can get close to it, but you can't pass it. You cannot pass that line. If you do, you're going to be in problems because you're going to go over to your neighbors, the property cannot be sold, and a whole lot of legal implications. The truth of the matter is, if you're still paying a mortgage for the house and the mortgage company comes and see that you've encroached, you can actually, um, they can actually repossess the property if you don't fix this stuff. So it's important. All right. So are there any other questions regarding the vertical asymptote and the horizontal asymptote?
No, not at the moment.
No,
Okay.
sir, not at the moment. Oh.
Okay. And you understand what I just talked to you about in terms of the building and you're not able to pass this and you can't pass that support and so on. It's real maths, you know. It's real mathematics we're talking about.
Yes, sir. Certain restrictions.
Yeah, man. Yeah, man. Yeah. All right, let's move now. So we're moving to my second slide that says no, um, it says recall, my f of x is going to be equal to x squared plus, sorry, over x plus 1. Now we are trying to
So
find
you
the
can
critical.
just go back to the next slide so I just do a screenshot, please.
Sure. I hope you're not driving, you know.
I'm home now, sir. Home.
Okay, cool.
Just preparing up. That's why I just want to take the screenshot instead.
Okay,
Okay, sir, that's okay.
good. So now, so what is happening here is we're doing the differentiation.
Mm.
So watch me. That's my function, x squared over x plus 1. It's and I
Oh,
should say, Bijan, I saw your stuff. I looked at it. I see you circle the x squared there, and I'm saying to myself, why I'm circling the x squared? This is the x squared at the circle right here, so. And as I was going to ask you, why are you circling that x squared? But anyhow, we'll come back to that.
Sir, when I reach
Arthur,
this-
yeah, and Arthur, I saw your stuff not too long ago, but I was in a class, so I can't comment on it because I've not looked through it. All right. So it's the quotient rule. The quotient rule is the denominator times the differentiation of the numerator minus the numerator times the differentiation of the denominator all over the denominator square. Watch me. The denominator, see it here, so,
times the differentiation of the
times the
new.
differentiation of the numerator. I'm differentiating the numerator, I'm going to get 2x. See it here, so, minus the numerator. See the minus sign right here? And the numerator is here. Times the differentiation of the denominator. When I differentiate x plus 1, I'm going to get 1. All over the denominator squares, x plus 1, all squares. This ends my differentiation. The denominator times the differentiation of the numerator minus the numerator times the differentiation of the denominator all over the denominator squares. That ends my differentiation.
The
What
first differentiation.
the first differential, right? What is required of me now is to fix it up. What am I going to fix it up? Okay, watch me. I'm going to remove my parentheses. So this 2x times this x is going to give me 2x squared. See it right here. So that's the conversation we were having, Bijan, yesterday. And that 2x times this positive 1 is positive 2x. See it right here. So, and this negative x squared times this one is a negative x squared. See it right there. And of course, the denominator, remember, as we said in calculus 1, we never ever expand the denominator. We leave it alone. We're not touching it. The most we do with the denominator is just increasing the power or reducing the power by doing some cancellation. But we're not doing any expansion. We're leaving the denominator as it is, x plus 1 all squared over x plus 1 all squared. Now, in looking at the stuff, I recognize that 2x squared and negative x squared belong to the same family, so I can group them. So 2x squared minus 1x squared is going to simply be equals to 1x squared. See it right here, so 1x squared. Then, sir, you have to say the 1. No, I could just say x squared. And the minus 2, sorry, the positive 2x is a standalone. It has nothing to be added to. So what is going to happen? I'm just going to put it back. The denominator never changes. Never changes. All right? And then now, so what it is that I have is x squared plus 2x over my x plus 1 all squared over my x plus 1 all squared. And of course, if I want, I could factor out the numerator since the x's are common and get x times x plus 2, right? If I want, because remember now, this is just the first part of the question because I have to differentiate that portion again. Courage was saying to us yesterday that, sir, I made a mistake because what I did was to use this and differentiate it as a product. And when she did that, she made an error. And then in the second attempt of the question, she used this format. It really doesn't matter which other formats you use. And I would agree, use the simpler of the two formats, because the truth of the matter is, this is a format that I use also when I was doing this stuff. Using this format here with the product is going to increase the difficulty level of the question, because you don't have to go end up using a product rule when you reach a numerator. All right, so we can use that one. So having done my first differential, I'm going to move, by the way, press pause, search and press pause. Is the first differential okay?
Yes, sir.
Yes, sir. Yes, sir.
All right.
Yes,
Respectfully.
sir.
Me have one problem, sir.
Yes, Bijan, go ahead.
With the first differential, right? Who you know?
Well, you know what?
All right. You see, like how you have the answer, we have the answer circle, right? So, or the other one over there, so. You have a problem with it, or you know when it done for some reason.
Right here, so there's nothing much I can say.
You remember when me asked to say if I write here, say done.
It's the second time you're asking that question. Let me just.
Yeah.
I'm gonna come to that. So because you're asking that question, you asked that question yesterday, and you're asking the question now, I know that it's a real problem. So give me half a second. Let me just make a comment first.
All right.
Respectfully, when I ask if you understand the same familiar voices from yesterday are the ones that are answering me, I made a comment in first semester that normally the students who don't talk up in class are the ones who will not pass the course. I'm not going to say anything more on that. When you don't respond to me, I don't know if you're understanding. This is calculus 2, you know. So Omi used to beat up my chest on in a day of calculus 2, because calculus 2 are big people work. And when you're doing big people stuff, it comes with big people responsibilities. So when I ask if you're understanding and I hear one or two people answer, I am moving ahead. And when I move ahead, as was the case last semester, and you don't understand, but you're not saying that you don't understand for me to even go through again, you get lost. And you're lost for this class, and come next class, because I'm building on what you are lost about, you get even further lost. And by the third class, you're almost not redeemable. And you know within yourself, and trust me, I know also. I just saying that to say, this is the second week of school ending. Pull up on the socks. When I ask the questions, I want you guys to answer me. All right, so you're asking the question. You asked me that question yesterday, Bijan, and the question comes back tonight. So how I know that this is finished? Because when I move to this stage, and that's why I moved to that stage, because I have a product in my denominator, x plus 1 times x plus 1, which is x plus 1 all squared. I want to see if there's anything in the numerator that I can reduce this denominator by. So when I factor out, I recognize that this product is x plus 2, but I don't have an x plus 2 here, so I recognize there is nothing more that can be done to this question. Then, sir, you can't cancel that x to that x. You're crazy. You can't cancel inside of a parentheses. So there's nothing more that can be done to that. So I know it's finished.
No, sir. You know what the happens today? Because me see that the 2 square, and I just know say something else could I do. And then tonight, I come now and say you put it over there, so we have it separated. So me just feel like something else they need to do.
No, man, right. But yeah, but that is it. Don't like this.
Okay,
right,
okay.
All right. So what we're doing now is the second derivative is very critical when we're finding the critical points. Then, sir, to find the critical point, to find dy by dx, then it said dy by dx equals to 0. Yeah. So we can go ahead and find the critical points now. Well, yeah, we can go ahead and find the critical points now. But there's going to come a point where we need to know, classify the nature of those critical points. Is it a maximum? Is it a minimum? Is it a saddle point? Is it a point of inflection? What is it? We need to do the classification. And in order to do the classification, the method that we normally employ is the second derivative. So how I normally teach this topic and how I normally do it is get the differentiation out of the way, because if you don't remember how to do the other parts, at least you will pick up your points for your differentiation. At least you'll pick up your points for your differentiation. It's very important. Extremely important. Trust me. If you follow the sound of my voice and what it is that I say in class on a Tuesday and Wednesday, you pass this course with an easy A plus plus.
Mm.
Just work with me. So I'm going to do the second derivative. How do I find the second derivative? By differentiating the first one more time. But you recognize the first derivative is a quotient. So again, I'm going to employ the quotient rule. It says the denominator times the differentiation of the numerator minus the numerator times the differentiation of the denominator all over the denominator square. The denominator times the differentiation of the numerator minus the numerator times the differentiation of the denominator all over the denominator square. Very important. Very important. Students are supposed to be eating, sleeping, and drinking differentiation and integration. Eating, sleeping, and drinking it. It shouldn't be a problem to you. Easy, easy, 1, 2, 3. Suppose you can teach differentiation now. At this point in time, anyone of you in class, suppose you can even go and teach a calculus component on the CAPE syllabus. Real talk. Let's go. The denominator, x plus 1 all squared, see it right here, so, times the differentiation of the numerator. This is my numerator. I'm differentiating the numerator. Differential of x squared is 2x. See it right here, so. And the differential of 2x is going to be 2. See it here, so I have a plus 2. So that finished because it says the denominator times the differentiation of the numerator. I've already differentiated the numerator now. Minus the numerator. See the numerator here? All of that is this. All of this here is this. Times now the differentiation of the denominator. The denominator is a power rule. This 2 come in front of here, so see it right here, so. This is going to be reduced by 1. See it here, so with the first power there. Sorry, you have to write the first power? No. But I'm just doing that for emphasis. Then I must now differentiate what is on the inside. And the differential of x is going to be this 1. And the differential of a constant is going to be equal to 0. So it's really times 1 plus 0, which is really 1. So this is going to be 2 times x plus 1 times 1. So this is a differentiation of the denominator. Then, sir, you did have to write this times 1? Yeah. Because what if this were 2x inside? Then this value would become 2. What if this were 10x? Then that value becomes 10 because you're differentiating what is on the inside of the parentheses. And no, this is over the denominator square. Now remember, not because this is already x plus 1 square, you're going to leave it like that. It is going to be x plus 1 square square. Because every time you're using the quotient rule, you're squaring the denominator every time. Now listen to me, you know. You see, when I move on to, which topic that now, Lord? Maclaren's expansion. A pair of them quotient, to something I'm not going to get, you know. I'm going to have to have the differentiation part, or else I'm going to lose some nice 10 marks and 12 marks. So it's the denominator square, square. So remember, recall, a to the m times n is going to be a to the mn. So I'm multiplying this 2 by this 2 to give me this 4. So I now have x plus 2 all squares, square is going to be equal to x plus 2 to the 4th. I'm looking to see here now, I'm fixing up my numerator. Fixing up the numerator. Look at what is happening. I'm looking to one side of the negative sign. There are 2 terms. This is one term, this is another term. And I'm looking to see what is common between the terms. I recognize that 2 times x plus 1 is common. Sir, how so? I'm seeing 2 times x plus 1 on this side, but I'm not seeing it on this side. Yeah, man, see it right here, so. This is the same thing as 2 times x plus 1. When you factor out the 2, see, the 2 is common. When you factor out the 2, you're going to have the 2 outside times x plus 1, all right? Or when you multiply this 2 by this x, you're going to get 2x, which is the same thing as this, and this 2 times this 1, you're going to get positive 2, right? So these 2 terms are the same, so I'm going to factor them out. And this is it. I'm factoring out the 2x plus 2.
There, yes, sir, no last minute.
Yes, sir. Run back a piece, sir.
Yeah, Minister, sir, all right, we have the x plus 1 squared, right? Yeah, right, that's what we have, that's what this is, sir. Plus 2, all right, we get that part there. All right. So at the front, when you say you get, because all right where you have x plus 1 squared times 2x plus 2. How you get rid of that? Or only think, remember, you times the 2x by the x and then the 2x by the 1. Also?
Right here, so that's what I just did. That's what I just did right here.
Mm.
So what I have right here, so this term is really the same thing as 2x plus 2, which is the same thing as this term here. So that's what I'm saying to you, that this term, which is 2x plus 2, is the same thing as this 2x plus 2 right there.
Yes, sir. I get it.
Yes, sir. Yes, sir. I get it. I get it.
Right. And which is the same term as this. So I'm factoring it out because this and this are the same term. So I take it out because I can only take out what is common.
Okay, all right. You see that little, all right.
Good. When I take out what is common, what is going to be left in my square parentheses is what is going to be what is left. When I take out this from here, so when I take out this from here, so what is left? Don't is x plus 1 all squared.
X plus 1.
X plus 1 squared and x plus 2x.
Yeah, this right there. So when I take out all of this, what is left?
X squared
plus 2x.
Minus x plus 1 squared minus x squared plus 2x.
Yeah, right. Got it. Right? So that is left. So now I have reduced it from here. So I've reduced this line here to now this line right there. So what is going to happen to me now is that this x plus 2, sorry, 2x plus 2 is going to remain outside, and I'm going to fix up what is inside here. I'm fixing up what is inside here. How do I fix up? By removing the parentheses. Now, x plus 1 all square. X plus 1 all square. X plus 1 all square is the same thing as x plus 1 times x plus 1, which is the same thing as that x times that x and this x times that, this times this times this times that. So what I'm going to have is x times x is x squared. X times 1 is x. 1 times x is x. 1 times 1 is 1. So what is going to be left is x squared plus 2x plus 1, which is exactly what I have right here, x squared plus 2x plus 1. And then I'm distributing this negative sign into this parentheses. So negative, and there's an imaginary one that is there. Negative 1 times x squared is negative x squared. See it right there, so negative x squared. And this negative 1 again times this 2x is going to be negative 2x. See it right there, so negative 2x. So what I would have done is to remove the parentheses within that square parentheses. Remove the parentheses within that square parentheses. And in so doing, what I'm going to do now, I recognize this x squared will cancel out with this negative x squared. Positive x squared cancel out with negative x squared. Positive 2x cancel out with negative 2x. What is left is this 1. That plus 1 alone is left. And then, remember we did say that 2x plus 2 is the same thing as 2 times x plus 1. And I am going to factor it now back into this 2x plus 1. Why, sir? Because I recognize that I have an x plus 1 to the 4th, so I can do a cancellation. So this is going to cancel into one of this, which will leave a remainder of 3. So I no longer have 4 of them down here. When I cancel this one out here, I'm going to have 3 of them left. So now what I'm going to have as my final answer is going to be 2 over x plus 1 all cubed. And that is going to be my second derivative.
Hmm. I need to review some materials.
Oh, yes. Not just,
Sure,
not just
give me 2 seconds to process this.
Yeah, I need to, yeah, probably should take a screenshot of this as well.
Sure.
Did you send out the course outline?
No, because I am yet to put you guys in edit code. It has been, all right, so graduation is tomorrow, and there are a whole lot of things that's happening. So forgive me. After tomorrow, things will be normal. By this weekend, things will be normalized. So forgive me. I'm telling you straight up. I can't do anything more. The time that I've done it today, I had to do my preparation for class tonight. So I was once you have access to the edit course off, you'll get access to the course outline. So I apologize for that. Please, I apologize. I really hope it is accepted. I will normalize things by this weekend.
Sir, recording as well, sir. Need to go over the
I will,
recording for the
I will
weekend.
just yeah, I will do all of those, sir.
Him, let's believe he's going to be.
Give me a minute, please. Okay. Tell me that I can move, please.
Just a minute.
What about the others?
Yes, sir, you can move on.
Yes, sir.
Yes, sir, you can go ahead.
All right. So now I'm going to be looking at the critical points. Looking at the critical points. For critical points, always set dy by dx equals to 0. For critical points, always set dy by dx equals to 0. You know what the critical point is? Sorry, you know what the first differential is? That's my first differential. I'm setting that equals to 0. Now 0 in this case, when you're working with a rational function, is going to be 0 over 1. It's going to be 0 over 1.
Sir,
Go ahead.
is that a fraction with the horizontal asymptote and the vertical asymptote?
No, it's not. It's not. It's just that whenever you have a fraction and you set in a fraction equals to 0, it is really always 0 over 1. Don't just put dy by dx here and just put 1, 0 right there. So put 0 over 1 because when you're doing this, you're cross multiplying. So it's not with the vertical asymptote alone. Yes, you would have seen me do that with the vertical asymptote in the first question that we did. But in this case, whenever you're having a fractional form and you're setting it equals to 0, it is always 0 over 1 because 0 over 1 is 0. Why are you doing that, sir? Because whenever you have two fractions separated by an equal sign, you will always cross multiply. So it's going to be the numerator times the denominator, and then the denominator times the numerator. So x squared plus 2x times 1 is x squared plus 2x. And x plus 1 all squared times 0 is going to be equal to 0. So I have reduced my rational function into just x squared plus 2x. Courage, I want you to unmute for me, please.
Sir?
Based on what you said to me last night, you only got x equals minus 2 for your critical value. True or false?
So I got the 2. I had 2 critical.
Oh, you got x equals 0 also?
Yes, remember I used the product on, so I did x equal 0 and x plus 2 equals 0. Yeah, just like that.
Okay. Fabulous. Thank you, honey. When I was preparing for class tonight, as I often do, I really hope you guys do the same thing. I reflect on the class before, on my previous class, and sometimes previous classes, because based on the questions that are asked, I'll say, okay, since Monday never did two. So just like I said, Bijan asked a question, or 2 times, Bijan asked a question, him asked it last night, and him asked a question tonight. I'm sure when I'm reflecting on class for next Tuesday, God's willing, I am going to be making reference to it, or I'm going to write a question so that it can help to concretize what it is that he's doing, all right? So that it can bring across some levels of understanding. Why am I saying this? I'm saying this again as a point. It's very critical for you to speak in class. You speaking in class will help me to help you to concretize those areas. Very, very important, all right? So I'm happy, but I want you to look at this here. When I'm factorizing my x squared plus 2x, I'm looking to see what is common. Now, what is common in that first term to that second term is x. So I'm factoring out my x. What is left? It's going to be x plus 2. Why we got that, sir? Because x times this x gives me x squared. And x times positive 2 gives me positive 2x. So it's very important for me to do that factorization. So therefore, either this x is going to be equal to 0, or the x plus 2 is going to be equal to 0. So it gives me this. And if x plus 2 is equal to 0, let me just put that there because someone will say, sir, oh, you get that. So let me put it there before you ask. So from here, I'm going to say x plus 2 is equal to 0. So therefore, x is going to be equal to negative 2. And that's why I get this negative 2 right there. All right. Now, what is important is those two values. Please note, do not divide throughout by x or cancel the x. So some students will say, oh, we can divide through by x. You can get x plus 2 equals 0 because you'll only have one. What's your... You'll only have one critical value. You'll only have one critical value, which is x equal.
Sir, you know, say I almost frightened me because me I want never something big wrong. I just want you missing and you make it so like that's what no. You actually wait me up. You
No, but we can't have one big something value. Teacher can't spell value. All right. So now what is important, guys, is you never divide, always factorize. That's the point. Never divide, you always factorize. Every single time you always factorize. Always factorize. One of the things, Tariq, is that when I present these notes are not notes that I take from a textbook, because I can't teach from a textbook. Me understand this stuff. This question is a question that I make up out of my head, but I know what I'm looking for. I know the level of difficulty that I want, so I just make up these questions. So when I put these things down, and I don't copy it from something, so I type it out of my head, and sometimes when I go back, like the other day, last week Wednesday, as a matter of fact, I'm reading the question and you recognize that I made some mistake with some negative sign there. I'm human.
yes,
And, yeah, it's and that's why I do the questions and I come back to class and I work the questions, and I'm encouraging you to work the questions because
sometimes you make mistake and we can
oh
see.
yeah. And guess what? Sometimes I deliberately make the mistakes and try to find out. And this is the honest truth. Sometimes I deliberately make the mistakes to see if you guys are going through the stuff. Like a pastor will go and say, okay, come next week, I want all of you to read Proverbs chapter 20, Proverbs chapter 32 for me. And then pastor come to church and say, okay, I'm going to read Proverbs. Let me see a show of hands of those who read Proverbs chapter 32. And you see people put up them hand in a church, but Proverbs chapter 32 does not exist. So, those who never did something at all. So sometimes I deliberately will make an error just to see if you guys are doing this stuff. But last week was a genuine one. I didn't do that deliberately. But it's important though, guys, that when I give you work that you make an attempt, all right? So please, you notice I didn't even write that. I make sure type it because I want you guys to see it. It says, please note, do not divide throughout. Do not divide throughout. Neither would I want you to cancel. I want you to factorize. I want you to factorize. You know what I'm going to do? Sorry. Always factorize. Always factorize. Always factorize. It can't go wrong. It can't go wrong. Please. With that said, so I have and these are known as critical values, don't it? Talk truth.
Yes, sir.
Yeah.
Yes,
Yeah, man,
sir.
they're known as, because points will include two something. These are those x values, and I don't have my f of x values yet. So these are critical values. So now, in order for me to get the critical points, x is equal to 0, x is equal to 0, x is equal to -2. X is equal to 0. I'm going to substitute into the original function. This is my original function given x squared over x plus 1. Anywhere in the function I see x, I'm going to put this 0. So this is 0 squared, see right there, so? 0 plus 1, right there, so. So I'm going to have 0 over 1. But 0 over 1 is 0. This is not the y value. See here, so? That. So when I put the two, something them together, I'm going to get 0, 0. So my first critical point is going to be 0, 0. My first critical point is going to be 0, 0. Similarly, I'm going to put the x equals -2 into my original function. Remember, it is always the original function that you use. always the original function. So watch me. The same something, you know. Anywhere in this, I see x, I'm going to put negative 2 sit here, negative 2 squares over negative 2 plus 1. Negative 2 squares is not negative 4. It's going to be negative 2 times negative 2 is positive 4. Positive 4. And negative 2 plus 1 is negative 1. So when you divide that, you can get negative 4. That's my y value. So when I put the x value to the y value, I'm going to have my coordinate, which is my critical point, negative 2 comma negative 4. So I have two critical points, 0 comma 0 and negative 2 comma negative 4. Any questions?
No, sir, understood.
Okay, so let's go to the nature of the critical points. The nature of the critical points is what I'm going to be using my second derivative for. I'm going to be using the second derivative. And I want you to remember this, you know, because when I move to stationary points of the multivariable functions, is the same something we're going to do. We have to find the second derivative. We have to find the second derivative. We have to find the second derivative. So please, the same thing we're doing over and over, just different functions we're working with. So what I taught you in last semester is the same concept that we're using for this semester. Let's go. So recall, this is my second derivative, 2 over x plus 1 all cubed. And then what I'm going to be doing now, I'm substituting my critical point. Now, these are single variable functions. These are single variable functions. So the truth of the matter is, for the it's just the x value alone you're going to be using. It's just the x value that you're going to be using. So anywhere in the function you see x, you're going to put 0. 2 over 0 plus 1 cube. See here? 2 over 0 plus 1 cube. 0 plus 1 is 1, and 1 cube is 1. So 2 over 1 is 2. That's 2. That's 2. So positive 2 is a minimum. It's a minimum value. It's a minimum value. Similarly, we're going to use the point negative 2 comma negative 4. We're using a point negative 2 comma negative 4. Negative 2 comma negative 4. Similarly, I'm going to substitute into my second derivative. So it's going to be 2 over negative 2 plus 1, which is this 2, and negative 2 plus 1 is negative 1. And negative 1 cube is going to be equals to negative 1. So 2 over negative 1 is going to be negative 2. It's going to be negative 2.
Yeah, I like it. Oh, you right. The critical points, you have minus 2 and minus 4.
Mm-hmm.
That drop.
Say it again, Bijan.
Oh, you drop in this also. A critical point, we have minus 2 and minus 4.
Mm-hmm. I'm determining the nature of the critical points. I've determined the nature of this critical point to be a minimum. I need to determine the nature of the other critical point, which is 2 comma 4. 2 comma negative 4. Remember, we got two critical points in them. 1 and 2.
Oh,
So
you do this. Oh, snap. No, what's that about? No,
yeah, man. Yeah, man. So I did this first one already. So we don't need to do the second one. And if I had 3, okay. So I have to look at them individually. So I know that this point is going to be a minimum. The point 0 comma 0 is going to be a minimum. Meaning, say, it will turn up because that's what the minimum is. Let me just put that there, because when I do the graph, you will see what it looks like. So the minimum is going to turn up. The maximum is going to turn down. And that is going to come in very useful a little later on when you see me do the graph. So anywhere in the function I see x, I'm going to substitute negative 2. See? Is 1 x in the function, right? Yes, so I'm putting negative 2 plus 1 is going to be negative 1. When I raise a negative number to an odd power, it's always negative. So I'm going to get a negative value down here. So it's 2 over negative 1, which is negative 2. And because it is negative, it is a maximum. Positive is a minimum. Negative is a maximum. Positive is a minimum. Negative is a maximum. All right. So having classified those points, the nature of the critical points, I'm now asked to find a point of inflection. Now, Corey says to me, sir, I have a problem because I can't get something with the critical point. And I said, okay, great. But let me show you something. Where possible, the point of inflection, where possible. So you never tell us it have a point of inflection. Where possible. The first one, sir, they have a point of inflection. Yeah. But we don't know. The one you said point of inflection, where possible. All right. So we use the second derivative and we're setting the second derivative equals to 0. To find the point of inflection, we're going to use the second derivative and we're setting it equals to 0. When we set it equals to 0, this is what is going to happen. We're going to have 2 over x plus 1 all cubed is equals to 0. But remember, when we're setting a fraction equals to 0, we are going to set it as 0 over 1. Why, sir? 0 over 1 is 0. But you need to know how to treat this fraction, because once you have two fractions separated by an equal sign, what do you do? What do you do when you have two fractions?
Cross multiply.
Cross multiply.
Every single time. Every single time. So this 0 over 1 helps you to know which number goes which. All right? So is this 2 times this and this times this? So 2 times 1 is 2. And x plus 1 cubed times 0 is x plus 1. No, 2 can't be equal to 0. 2 cannot be equal to 0. That's inconsistent. So there's no point of inflection. It's inconsistent. How 2 must equal 0? Can't work. Can't work at all. There's no way that can work. So guess what? There's no point of inflection. But sir, how can you do a question and you do have a point of inflection? Okay, fine. When you see the graph, you'll see what I'm talking about. All right? So there's no point of inflection there. And then now we're going to plot the graph. Now there are several things that must come out on the graph. The critical points are 0, 0 and negative 2, 4. Nope. Negative 2, negative 4. All right. Point of inflection, there is none. So here, critical points or turning points. I put TP right here when I plot the graph. Critical point, turning point, or stationary point. All of them mean the same thing. All right. So this point is going to be my 0, 0, and I color it because I want you to see it. 0, 0 is this point. And that's the first setup. The first thing that I did was to put in my asymptote. And I should color that, you know. What is wrong with me? I'm putting in my asymptote because I want you to see my asymptote. My vertical asymptote occurs when x is equal to negative 1. And my horizontal asymptote is going to be when x equals 0. Right? X equals negative 1. So my vertical asymptote is when x equals negative 1. It means that the graph can't cross it. That's what it means. So the graph when we put up here, so can't pass a line here. And the graph on the other side, they can't pass a line here. Can't cross it. That's what the asymptote means. Then, sir, with the horizontal asymptote, yeah, you can sit down on that. Because remember, the horizontal asymptote, we can cross over the horizontal asymptote, you know. You can sit down on the horizontal asymptote also. But the vertical is what is critical. You can't do that. All right? So watch me now. I put in my asymptote. Me get them points here. Remember, you know, when you're doing the question, everything, when you're in a critical point question, that is, everything that you would have done must be on the graph. And you know this from long time. So I put in my asymptotes, we get that. My critical points, we get 0, 0, sit here, put that in. We get more points. Negative 2, negative 4, negative 2, 1, negative 2, negative 2, negative 2, negative 3, negative 2, negative 4, boom. Put in my second critical point. We get more points right there, say no. And then, ouch, and then I don't have anything else to put in because there's no point of inflection. There's no point of inflection. So now what I need to do is to sketch the graph. Jeez, sir. How you know so the graph cut up so, sir? I mean, I see some more points to plot. All right. So when I plotted the graph, I know the graph will come right here. So it will come close to this one, but guess what? It must pass through this. So I'm going to put this and make it go. And the further up I go with the graph is the closer I get it to the x equals 1. So I know that this point is correct, but we never know how the graph behave right here. So I know how the graph behaves right here because it cannot pass. It cannot pass this vertical asymptote x equals -1. Can't pass it, right? But I know it can come down and it must go through this thing. And remember I said to you, minimum turn up, 0, 0 is a minimum it turn up. Minimum 0, 0 turns up. So I know say the graph turn up because I know it's a minimum. Maximum turns down. So I know -2, -4 is supposed to turn down because it's a maximum. See to yourself, bam, turns down because I know it's a maximum. So everything that you do in your calculations will come out on the graph. All right. So I know this piece not going to go down, it'll go up. Let me explain this piece here. So now, I did not know how the graph behave on this side. Honestly, I just did not know. So I had to investigate a little further. So I said, all right, when x is equals to 1, how the graph look? I'll go back up to here. So go back up to here. So and look to see when x equals 1. 1 squared is 1. So you know 1 squared over 1 plus 1 is equals to 1 over 2. So it's going to be a half. So if this is 1, that means half come right here. So that's how we get this half. So I'm just pop it right there. And then I said to myself, you know what? Let me see what happens when x equals 2. It's going to be 2 squared over 2 plus 1, which is equals to 4 over 3, which is equals to 1 and 1/3. So when we take a past 1, and then also up here says 1.5. So we just estimate 1/3 to be right here. So, right? All right. And then we say, all right, one more time. One more for the charm. When x equals 3. 3 squares over 3 plus 1. 3 squares is 9. And 3 plus 1 is 4. 9 over 4 is going to be 2.25, right? 2.25. This is 2. Up here says 2.5. Me estimate a quarter to be right here. So have to be below this. So we may do that now. We just say, no, boom, draw it up. So it's a sketch. It's a sketch. So it's not supposed to be accurate. It's a sketch. So that's how I get this part of my graph up here. All right. And then now down here, so we say, I already have this part. So I say, you know what? When x is equal to -3, I'm going to have -3 squared over negative 3 plus 1. Negative 3 squares, sure. Negative 3 plus 1. Negative 3 squares is 9. 9 over negative 2, which is going to be 4.5. Negative 4.5. So when it is negative 3, it's going to be negative 4.5. Now negative 4 is right here, so. And if 5 right here, so negative 4.5 is going to be right here. So come and get the point here. All right? And then I say, no, I'm going to check what 4 is. So it's going to be negative 4 squared over negative 4 plus 1. Negative 4 squared is going to be 16. And negative 4 plus 1 is going to be negative 3. And negative 3 into 16 is going to be negative 5.33. So negative 5 is up here, so. Negative 5 is up here, so. Down here says negative 6. So it's going to be, it not really reach 5.5 as I have it here now. It's supposed to be a little further up here, so. So let me just correct that. So it's supposed to be negative 5, when it's negative 4, negative 5, negative 5.5, negative 5.33 is about right there. So that's right. Sure.
But sir, it's just a sketch, right?
I know, but you see, somebody could tell me in the something, then sir, how I wanted to look so. Somebody can come to me and tell me, sir, how I wanted to look so. So me know it's a sketch. Right. And that's why I get my graph. And then that is it. So I agree it's only a sketch, but I want the sketch to be plausible. And you know, some suffer from OCD already, so you know that. Right? So that's also how you get the sketch. And then finally, kind of feel tired, guys. I had a class earlier. Finally, I went, oopsie daisy. What is wrong with the teacher tonight? Finally, so courage, unmute for me, please, on the bunches.
Yes, sir.
Were you honest with your teacher yesterday? Teacher said to you, do not do Desmos first.
Yes, sir, but I came to realize I really didn't understand the graph. How to plot the graph.
You don't understand the graph?
Yeah, I didn't understand it until I went to Desmos.
And that's why I made the comment, because I know this graph was going to look away. So that's why I said what I said, but no problem. So when you look at the graph plotted on Desmos, you'll see that I pretty much ish would have got the same thing because my x equal 1. Am I allowed to write on this? All right, hold on there. Hey, me like when my teacher and students understand. I don't know all students come to class and sit down and don't participate for learning. Hey, learning is such an important. You learn every day. You go work, you learn something new. Well, hopefully. Yeah, must come to class and sit down and learn, man. Watch me now. Let me show you something. Jesus. X equal 1 is right here. So, whoopsie daisy, not there at all. X equal 1 is this line here. Sure. You know what? X equals negative 1 is right here. So just watch this line. Boom, 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 boom. I think it's time I can't draw a straight line. All right. So that is your x equals 1. And then now your x equals 0 is here. Right. And this is your -2, -4. And this is your 0, 0. And those are the other two values. And that's it. And this is your function f of x to be equals to x squared over x plus 1. Tell me, I want to feel now. When you can't make me alone, enjoy
the x equal -1. Is there a reason why you can't pass the
Yeah, that's a
line?
boundary. That's a boundary. Can't
Okay.
pass it. The graph is undefined. So this graph here, this part of the graph here is
Yes.
undefined going over this side. So this graph can go anywhere over here, so can't cut over here, so follow me?
Okay, so anyway, you have the vertical acetone and the horizontal.
Right.
That gives
And
you an idea of
right.
where the graph can go from where it can.
Yeah. And then now that graph here, I have to go still over in this quadrant.
Yeah, over the next side.
Can't
Okay.
pass over here, so we can't
Can
wish to over this.
Can pass over this and it can pass up to the 0.
Same way, so.
Okay.
Same way. All right.
So
So
I
the
have
next
understanding of the graph. I think, and I figure out that I need to put some more work into the differentiation part. So I realize that's where
all right. Okay. You say you understand the graph. That's what you're saying, hon?
I'm understanding the graph. Yeah, the graph is not. My issue is to get the working. Is the differentiation I'm struggling with. So I need to practice that. Yeah.
I can do the differentiation. It's when I reach to the next line. I need to work on that to get it. Especially when you have the first the f of x, the first difference is okay, but the second, because you know that function is gonna be one big function.
Yeah, the second one.
All right. So so having completed the question, just let me do some little housekeeping because I'm going to do about what time is it now? 8:30. I'm going to do maybe about another 15 minutes of class and then cut it. I had a chemistry class earlier today, and I'm kind of going.
So when we get the recording,
as I said before,
not sure.
No man, it's working, The recordings come to me now, but the truth of the matter is I have been doing a lot of I'm focusing on the prerequisite overrides because the students are complaining, say they want to select them courses and so forth. So you know what I'm gonna do is all right. Let me sit up after when I cool off a little bit later on.
Ask because I don't have weekend off, but I have tomorrow off and so.
No problem.
And Friday, I want to go through the
I will do it. I will send it off. And for those of you who are joining Bijan and Andre, if you look into the description for the WhatsApp group, you'll see my YouTube channel. That's where I put all the recordings. So what you can do, none of you should even be complaining and say, sir, when am I going to get a recording, sir? When am I going to get a recording? You have a whole heap of calculus 2 into the YouTube channel. And I've said to you before, what I want you to do, just scroll through the channel. You'll know which one is calculus 2. You'll know which one is calculus 1. Go to the YouTube channel, look at areas that I would have done and would have taught in the past, and look at those. Maybe I teach something better, a better understanding 3 years ago than the understanding that I'm giving you guys now. Just go through the stuff. You have access to all the recordings. You have my class is better than the other classes. Let me not say that. I mean it in a good sense.
That's humble,
What I mean, let me explain what I'm talking about. What I mean is, I don't want it to be misconstrued. based on how I do my stuff in terms of creating a YouTube channel, it means that my students who are doing Calculus 2 with me have access to Calculus 2 that I did last school year, and Calculus 2 that I did the school year before that, and Calculus 2 that I did the school year before that one. That's what I mean. I don't know if any other lecturer is doing what it is that I'm doing in terms of having the YouTube channel where students have access to all those recordings. And I know one of my past students who had to do some work over for me was saying, sir, I just went into the channel and I was just following what it is that you post because I mean, it's there. So I'm finding the YouTube channel to be very useful. So I'm saying to you, when you're bored and you want work to do, just go to the YouTube channel. In the channel, you'd have seen me work past papers before. The same set of past papers that I'll work with you guys. So just go through the channel, look at the stuff. I'm going to be doing many topics. Newton, Ramson, Taylor's, Simpsons, Maclaren's, integration, whatever it is, go through the thing, look at the stuff, save the videos. You don't have to listen to the talking like what I'm doing right here. No, you just scroll through the lesson and just work ahead. That's why I do what I do. All right. Question. Are you understanding what it is that is being done or has been done?
Yes, sir, I understand.
Nice. I'm happy. Are there any questions though? Is there anybody in the class that is, you see what is happening, but boy, sir, this look like my for take the weekend for go through the something and catch up, and is there anybody like that?
Yes, sir.
Yes, sir.
Somebody
Especially with the
stage
graph.
them.
Yes, sir.
All right. I was like that too when I was going to school. It's not a bad thing. So when I was going to school, I wasn't one of the brightest ones in class. You had people who were way brighter, and as the teacher puts the information on the table, them just take it up. Me would have said, but sir, how you get that? And I said, okay. But it's when tests run and them get them big score, members send me there behind them. Them bright, you know. And then I said, so oh, you going like you don't understand. You know what I had to do? I have to go home. And when I know see them asleep, me up at the work. Me up at the work. Because I know I wasn't catching it as quickly as they can. So I have to go on the work, do extra work. Extra work.
Yes, sir, that is true, sir. But honestly, sir, it rough when you have so much courses to finish. Trust me, sometimes you want to dedicate some of the time, and it's just a lot. Trust me, just believe.
Let me tell you, Otto. Because the same variables that you have, are the same variables that I had. So I was doing the sciences and I had stuff to do, but you know what I did? I had a timetable, and if I know I have only 3 hours of work, and if I'm doing the 3 sciences for argument's sake, I said to myself, 1 hour for each. And I trusted my teacher to make sure that my teacher is going to complete the syllabus. So what was important for me is everything that the teacher did in class. It was important for me to be on top of those things because I'm sure when the teacher comes back to the class, the teacher is going to build on the information presented in the previous class. So I would never have gone to a class without understanding what was done before. And if there are areas that I don't understand, and the other day I found some of my books and I saw it. I used to create bubbles. Let me show you what bubbles are. And I still use bubbles surprisingly to this very day. Oh, sorry. Sorry, I just made a boo-boo a while ago. Let me show you what bubbles are. See them there? So them something here, them if when I'm going through my stuff and I don't understand something, I write a question and I put a bubble. And I always had colored inks when I was going to school, and I bubble those. And when I go to class, I ask my teacher, sir, XYZ, and the response that I get, I'm writing it beside the bubble. So when I'm studying again, I can remember for each question that I had, I'm asking him. So guess what? I'm not like, oh, some of you not go to class and sit down and go like, when they can't talk. Me and my teacher have to talk. Have to talk to my teacher so I can understand and get the stuff. And that's what I did. That's what I did. I would sit up at nights and I would study. So Otto, I hear you know, but you know what is important? You do the stuff in bite-sized pieces. Don't wait until it's mid-semester time when you have all the mid-semesters coming up and you don't have enough time to study. You do your weekly work, your hour, or you want half an hour, or whatever the situation is. You get one little free time and you put in some work. And when you put in your work, trust me, you're not going to lose the work. Anything that you put in, you won't lose it. But what I find is that when Sir done class tonight, when I lock the book, and Calculus 2 is not until next week, Tuesday, God's willing, and the book is opened next week, Tuesday. People don't do the work. And you may understand it in class tonight, but by time Sir log off and you open the book 3 days later, oh, Sir didn't get this again because they never put it to long-term memory. How do you put it to long-term memory, sir? By going over the work. I'm not saying that you have to go over the work tonight because it does not dissipate out of your headspace so quickly. But you have to put your work in. And I guarantee you, once you do that, difficult courses become easy. It don't have to be maths alone. If you're doing any programming or anything of the sort, little bite-sized pieces. Make your flashcards and you're good to go. All right.
Sir, may I beg you to send me that something? Sir,
I sent
This?
you you're right.
All right.
But I true you talk with the YouTube,
So did
sir.
you speak about Elicosoft? When it's going to be up?
It's going to be up. It's going to be up. All right. It's going to be up. It's going to be up by this weekend. It's going to be up. It's going to be up.
Okay, sir.
Yeah, it's going to be up. It's going to be up. It's going to be up. I
Okay.
promise you. All right. Yeah, man.
Sir, true you talk about your YouTube, all of the video them labeled with calculus 2
Yes,
from
man.
calculus 1 in the hard to find. So, all right.
Is it me? I'm telling you, me no, man. I do it because I want to help you students. So when I not do that, I don't want to help you.
You're muted.
Being recorded.
So are you saying something?
Oh no. Sorry. We just kind of feel tired a while ago. I'm actually trying to send you guys something, so that's why I was so silent. All right. So I just sent you a document a while ago. Check to see if you get it, please.
Yes, sir.
Receive.
All right. So that's the beauty about technology. So anything I write now, you can get in a few seconds. So
So a question about Educosoft. When do we start the assessment?
all right. You know what I'm gonna do? This is only 20 minutes. All right. Let me not even start that. All right. All right. Let me just do this in class now and then send you off. Then Get your devices open for me, please. I'm just going to just add you guys to Educasoft now.
Okay, sir, no problem.
See that everybody's so anxious and excited, and I don't want nobody to say, boy, sir, I was so excited, they never put me to Educasoft. Say, you know what? Let's go.
Sir, I wouldn't be added to Educasoft, right? Or persons like me.
Right, it's right, you're correct.
To be at Microsoft yourself, you have to select the calculus tool, right?
Yeah. No.
Huh?
No, Educasoft is different from Erie and Crossville.
Oh.
Bijan, may I have your ID, please?
2015, 10, 14.
Sorry, no, that's not what I meant to ask you. Forgive me. Give me your email address. Forgive me, your email address.
Oh, Jones.Bijan. Wait.
Your ECC one.
Yeah, that remember I said that there you go. Bijan.Jones. 43.
EJUAN?
BEJAUN.
JAUN. Dot Jones?
Yes, sir.
What number?
43.
Okay. My. Bijan, you're added. Check for me, please, to make sure that you get it. Francis, I think. Is it Francis?
Sir, we have a small emergency.
Come on, you can run. Cool. Francis? Where is he? Oh, he's not here. Okay. Francis is not here. All right.
Sir, I see a message here, that email.
All right, cool. All right, cool. All right, so you can run now, because I'm not going to do anything else. So you can run here, Papa. The rest of you, I'm just going to promote you. So, I'm going to promote you guys. So you won't get a notification like Bijan just now. You have to log on and then tell me if you see the stuff. So when did I teach you? I taught you semester 1, 2021, 22, or 2022, 23. 22, 22. Oh, Rockstone. I can't promote you because I reopened the stuff. Oh, Lord and Father. Oh, man. Oh, man. I'm not going to be able to do it because oh, man. All right, so I'm finding Autoly, so I can do Autoly from there. Utterly, Utterly, you have been registered because I find you. Oh gosh. Term 1. All right, Tiana, I just gave you your access, Tiana, so you have access now because I'm finding you elsewhere. Hmm. All right. Check for me, please, Auto, that you get the stuff. A quick question. You guys used Edicosol for prob theory, for probability,
And statistics.
prob and stats, yeah. Did you?
Yes,
Yes,
sir.
sir.
All right, hold on. Let me just try and cheat the system.
No, sir.
Well, I know you wouldn't. When you did prob and stats, the rest of you.
So repeat.
When
Checking
you did
now, sir.
when I did prob and stats, what year you did prob and stats?
2021.
2021.
Yes, sir. 2020, 2020, 2021.
Who taught you?
Semester.
Rookwood or Sir Francis?
Mr. Rookwood.
Mr. Rookwood. All right.
Miss Francis for me.
All right. Hold on. Hold on. Let me just. All right, Crosswell. I found you, so I'm transferring you. So Crosswell, you have access to Calculus 2 now from. I'm trying to cheat the system. All right, let me do Mr. Sir Francis and see. Crossdale, you're 91. Crosby. Tajay, you're 6'9".
Yes, sir.
So you're 6'9". Tajay is 6'9". All right, Tajay, you have been transferred.
Okay, thank you.
I'm going to transfer this Crossdale because I think he's the owner Crossdale here. The rest of you just log on to just make sure that you have access, please. I'm just trying to. Okay. All right, so let me just check my class. So far in my class, I have Arthur Lee, Michael, Bijan, Tajay, Tiana, and Crosswell. Lotto, give me your email, please, Lotto.
41.
41, good.
Yes, sir. That's the LATOYO.DAVY 41.
41 at my.ecc.edu.jn. All right, Lotta, check to see if you get a notification.
Okay, sir.
Who else is here that is not yet added to Edico? Can just give me info a second.
Sir, I think I'm not added as yet, sir. Come on, sir.
Give me your email, please. Come on.
Come on, that Earlington 29 at myecc.edu. That's it.
All right, you're 29.
Yes, sir.
EARLINGTON. Come on. All right, who is next? Come on. Oh yes, John. I'll come in. Let me just look at John. Check Kamoy, please. JOHNNA.HALL. What number?
09.
Check for me, Joe. Who's next?
Tariq, sir. Mendes.
Okay. TARIQ.MENDEZ. What number, Tariq?
09.
09. Ooh. Come on, sure. TARIQ.MENDEZ09 at
Sure, I got you.
Good job. All right, check for me, Tariq, please. Who is next?
Rajay, sir.
Tajay?
Rajay, sir.
Rajay, sir.
Oh, Rajay. Oh, good night, sir. RAGEH. Dot.
Oh, I got access, by the way, sir.
You got it? You got it?
Yes, sir. Tajay.
Okay, cool.
Oh, cool.
What's the email, Rajay? Remind me of the email, please.
Rajay.row68 at
68.
my ECC.
I just never know the last number. RAGEH. RAGEHROWE68 at my.ecc.edu.jm.
Yes, sir. Tariq, get it, sir.
Good job.
No assessments, sir.
No, man, I'll fix up that, man. I'll fix that up.
Okay, sir.
And I'll add the syllabus to it and everything.
All right, sir. Thanks.
Yeah, that's it for the night. I'm not doing anything else.
All right, have a good night.
To you, to Papa. All right, Rajay, you are there. Please check before you go. Who is next?
Correct, sir.
Oh, yeah. All right, my love, you have to help me out now with the spelling
No
of your
problem.
name. Go for me.
Okay, OLU.
OLU.
WA.
WA.
PELU.
PELU.
MI.
MI.
Dot IG.
IG.
WE.
WE.
BUIKE.
BUNKE.
No, BUIKE.
B-U-I-K-E.
48.
Okay. Igwebuike, or how you pronounce that?
Igwebike.
Igwebike.
Yeah.
And how you pronounce the first one?
Oluwa Belumi.
Olowa Pelame.
Belumi, yeah.
Pelumi. I have to know this, you know why? Because I don't know, maybe for the award ceremony, I forgot to call the name. So Oluwa Pelame. Oluwa Pelame. Igwebi. Igwebi. What is that?
Igwe.
Right, guess what? That's homework. Homework. I forgot that. So 48 at my.ecc.edu.jm.
Jay got it, sir.
You got it? Very nice.
Yes,
So you
sir.
can
Good night.
Good night, Papa. Pelumiguike. All right, Courage, you're supposed to be there. Check for me, please, and let me know. All right, so I'm only seeing Crosswell, Courage, Otterly, and Lotto in class, and all of you I know have access to Edico, so I can say, have yourselves a wonderful good night, and I will add the other stuff to your stuff for you.
Okay, sir. Good night.
Yes, your heart. Take care.
Peace and
Okay,
God.
so good night.
Yep. Yeah, man. Take care.